Good afternoon to all of y'all. In this video, we wish to see what is a central force. If we have a particle of say some mass m1 and there is a force on it, let us say there is a force on it. Yes, there is a force F on it, and we find that this force is always directed towards a fixed point. This fixed point is called as the center. This fixed point is called as the center, and hence the name central force. So it is pointing towards the fixed point. Yes, and the magnitude of F depends only on this distance d. So the magnitude of the force F depends on the distance d of the particle from the fixed point. It is always pointing towards that fixed point, and this magnitude is independent of time. It doesn't matter at what time m1 is at this position. Also, if m1 were somewhere here and let's say the distance were the same d, the magnitude of the force would be the same, and the force would still point towards the fixed point. So if these conditions are satisfied, we call the force as a central force. The gravitational force and the electrostatic force are central forces. Let us see the gravitational force. We know if there are two particles m1 and m2 having masses m1 and m2, then by the Newton's law of gravitation, these two masses will attract each other with a force F. This force F will act in pairs as per the Newton's third law, and they will act along the line joining the two particles, and the magnitude of F would be g. G is a universal gravitational constant, m1 m2 by d square. Yes. So this is the Newton's law of gravitation. Now let us see how these forces satisfy the conditions of a central force. First of all, we have to identify the fixed point. Now any point is fixed or moving with respect to a frame of reference. So we need to choose a frame of reference in which we can identify a fixed point. Now the fixed point cannot be somewhere here, for instance. This cannot be the fixed point. Why this cannot be the fixed point is because the forces are not pointing towards it. So the fixed point cannot lie outside the line joining the two particles. They must lie on the line. Now the fixed point cannot be on the particle m1 or on the particle m2, because m1 and m2 itself may be moving. So the points will not be fixed. The most obvious thing seems to be the center of mass. Supposing the center of mass is somewhere here. Now the net force on the system is 0. So therefore the center of mass would either be at rest or move at a constant velocity. That is by the Newton's first law. So therefore we can choose a frame of reference in which the center of mass is at rest. Yes, so our frame of reference is chosen in such a way, we will call this as the C frame, center of mass frame. So if you choose a center of mass frame, that is a frame in which the center of mass is at rest, that center of mass can be treated as the fixed point. This should be the fixed point or the center. Yes. Now the question is, how is the force dependent on the distance between the particle and the center? Suppose I call this distance as r1, and let us say this distance is r3. Yes, that's the reason why I am not calling it as r2. Let's call it as r3. And let us now see uh, how the force is dependent on r1. We said the distance between the two particles is d. Now we know by the basic definition of center of mass, the uh, coordinate of the center of mass, the coordinate of the center of mass is equal to m1 x1 plus m2 x2 by m1 plus m2. Correct? The coordinate of the center of mass is given by m1 x1 plus m2 x2 by m1 plus x2 for the two particles lying on a straight line. Now, if you choose the center of mass as the origin, the coordinate of the center of mass would be 0 because you have chosen the center of mass at the origin, and you can take r1 as minus r1, that is the because it is to the left of the center of mass, and r3 as plus r3. So I can write this as m1 minus r1 plus m2 into plus r3 by m1 plus m2. That will give us r1 by r3 is equal to r1 by r3 will be equal to m2 by m1. That is, the center of mass divides the distance between the two masses in the inverse ratio of the masses. Now we know the total distance between the two, or the distance between the two particles, is d. So we can get r1 as d by the ratio is m2 by m1. So the total number of parts is m2 plus m1, and you take m2 parts. So r1 would be d by m2 plus m1 into m2. Similarly, r3 would be d by m2 plus m2 plus m1 into m1. Yes, if you add these two, r1 plus r3 will give you d. Yes, r1 plus r3 will be d. So what we can do is, in this d here, we can substitute in terms of r1. So I can get f as g m1 m2 by d would be r1 into m2 plus m1 by m2, m2 plus m1 into r1 by m2, this whole thing squared. Now m1, m2 etc. are constants. So therefore you find that f is inversely proportional to r1 squared. So this force is dependent only on the distance of the mass from the fixed point or from the center. We have proved that. Similarly, this force we can prove is proportional to 1 by r3 squared. If you use this formula to replace d in terms of r3, you will get the force inversely proportional to r3 squared. So therefore we have proved that the gravitational force is a central force. Yes, the force is always directed toward the center, and the magnitude of the force depends only on the distance of the particle from the center, and it does not change with time or with other positions as long as the distance is the same. Now you take charges. For like charges, it would be like gravitation. The forces would be for unlike charges, it would be like gravitation. The forces will be attractive. But for like charges, the forces will point away from the center. They will not be directed towards the center, but they will be away from the center. Now, what we wish to see is that how these two particles will move under the influence of the central force, how these particles can move. One thing is very clear, that the center of mass will always lie between the two masses m1 and m2. Yes, it will always lie between m1 and m2. So whichever way m1 and m2 move, the center of mass must lie between the two. Now supposing these two masses were at rest, if these two masses were at rest, they would move towards each other along the straight line joining them, and they would collide at the center of mass. Yes, but also if their velocities were along if their initial velocities were not zero, but it was pointing in the direction of the line joining the two, still they would collide at the center of mass. But what if the velocities were something like this? If v1 was something like this, and let us say v3 is something like this. Just shown an example where the velocities are not along the line joining the two. Then the path would be a curve. The path would be a curve. Yes, the path is going to be a curve. Now this curve can be a closed curve or an open curve. The closed curves that are possible are the circle and the ellipse. And the open curves are the parabola or the hyperbola. Yes, parabola and the hyperbola. When you have a closed curve, we say that the system is bound. That is, the two masses do not move away from each other and tend to infinity, and do not try to have infinite separation, but they move staying together. So that is what we term as, when you have a closed curve, we say that as a bound system. On the other hand, if the two masses move away from each other towards infinity, then the curve would be open and is called an unbound system. Yeah. The system is bound if the velocity is less than the escape velocity. There is a way to calculate the escape velocity. We will not go into that. But if the velocity is less than the escape velocity, the system would be bound, and the paths of the two particles would be a closed curve. It would be a circle or an ellipse. On the other hand, if the velocity is exactly equal to the escape velocity, v is exactly equal to the escape velocity, then the path of the particle would be a parabola. And if the velocity is greater than the escape velocity, the path would be a hyperbola. Under the influence of the central forces, these are the only four types of curves that are possible. Of course, it can be a straight path, or it can be a closed curve, circle or ellipse, or an open curve, parabola and hyperbola. No other curves are possible with a central force. The proof of this, the mathematical proof of this, is a bit tedious. We will not go into this, but we will just take it for granted that the closed curve follows any of these. Now, when is the closed curve a circle? When if I have these two particles M1 and M2 here, let us say this is the center of mass. Let us say this is the center of mass, and supposing the velocities are perpendicular to the radius vector r1. If I call this as r1 and let me call this as r3, yes, if the velocities are perpendicular all the time, then the paths are going to be circular. So if you take M2 for M2 it would be a circle like this, and for M1 it will be a circle like this. Now you must note that the sense of rotation of both the particles will be the same. Now if you take M2 is moving in the anti-clockwise sense. M1 will also move in the anti-clockwise sense. Why this is necessary is because the two particles have to be on either side of the center of mass or the center at every instant. So if this moves towards the right, this must move towards the left, and hence the sense of rotation will be the same. If the velocities are something like this, that is, they are not perpendicular, then what do you have? You have a situation where the path could be a parabola like this. The two paths could be parabolae like this, and the center would now be the focus. It would be the focus of the parabola. So if I draw a line from one curve to the other, if mass m1 is here, mass m2 would be somewhere here, and this focus would be the center of mass. That focus F is the center of the central forces. Yeah. Now, again the sense, if m1 is moving say towards the right with a velocity v1, m2 would move towards the left with a velocity v3, where we have said this is r1, vector r1, and this is vector r2. Yes. So as you can see, m1 would move this way to infinity and m2 would move this way to infinity. Yes. So both of them, this is a case of unbounded system. The two masses are not bounded. They tend to move towards infinity and have infinite separation. Yes. So this is a case where it is a parabola or a hyperbola. In the case of an ellipse, if I draw one ellipse and another ellipse here, yes, an ellipse has got two foci. This ellipse would have two foci. This ellipse also would have two foci. But one of their ellipse, one of their foci would be common. That common foci becomes the center. So if I draw a line like that, if m1 is somewhere here, m2 would be somewhere here. Yes, the common foci becomes the center. If m1 is moving the velocity, say va, like that, m2 would be moving the velocity vb, like that. And if this is ra and this is say rd. So again, as you can see, the sense of rotation here is the same. This is moving in the anti-clockwise sense. This is also moving in the anti-clockwise sense. Okay. Now, we shall now write this F, this focus we said is the center of mass. So therefore, if we choose the origin at the center of mass for this ellipse, or for the parabola and hyperbola, or for the circle, whatever be the case, we can say M1 RA plus M2 RB by M1 plus M2 equal to 0. If we choose the center of mass as the origin. Yeah. Now, from this we get M1 RA is equal to minus M2 RB. Or you take the modulus value on both the sides. You take the modulus value, you get M1 RA is equal to M2 RB. Yes. Now, if you take the major axis of both the ellipses, you take the major axis like that for both the ellipses, it is very clear that when this particle M1 is at this maximum, is at its maximum distance, when that is maximum distance, that is also called as the apogee position. When it is at the apogee position is maximum distance. The other particle will also be at its maximum distance. M2 will also be at its maximum position. And let us say the distance from the foci is R1 and the distance of this, let it be R3. Yeah. So we can say for the apogee position M1 R1 is equal to M2 R3. Now when this particle moves and comes to the nearest position, that is called as the perigee position. So when it is at the perigee is the minimum distance. Perigee is the minimum distance. That is here. If I call that as R2 and that is M1 is at R2 and M2 is at R4. So we can say M1 R2 is equal to M2 R4. Yes, by this equation R1 M1 RA equal to M2 RB, we get this. Now if you add these two, you get a very interesting. So M1 would be common, you will have R1 plus R2 and you will have M2 into R3 plus R4. Yes. Now R1 plus R2 is the distance of the length of the major axis, which is 2A1. So I can say it is M1 into 2A1. R1 plus R2 is 2A1. This will be M2 into R3 plus R4 will be the major axis of the other body. That is 2A2. So therefore, you have this relation for elliptical orbits. M1A1 is equal to M2A2. M1A1 is equal to M2 into A2. Now, let us do another interesting thing. Let us differentiate this. If you differentiate this, you get the velocities with respect to the center of mass. So we have m1 r1 plus m2 r3 equal to 0. We have from this equation. If you differentiate this, you get m1 v1 plus m2 v3 equals to 0. Where v1 and v2 are the velocities with respect to the center of mass. v1 and v3 are the velocities with respect to the center of mass. Why do you say it is with respect to the center of mass? Because you have taken the positions with respect to the center of mass. So if you differentiate the positions with respect to the center of mass, you will get the velocities with respect to the center of mass. So you will have m1 v1 plus m2 v3 equals 0. This is nothing but the linear momentum of the system. So the linear momentum of the system with respect to the center of mass is always 0. That means these two vectors will always point in the opposite direction. So if you take here for in this case, V1 is this way and V3 is this way. Both these will be pointing in the opposite directions. Similarly here this VB and VA, they would be pointing in the opposite directions. Yeah. Then the next thing in the case is that the force which is there, the forces along the line joining the two. Now that force passes through the center of mass or center or the foci, whatever you call it, but the center of the central force, the force passes through the center. The line of action of the forces passes through the center of the central forces. So therefore we can say the torque of the forces about the center is 0. Because the torque of the torque about the center is 0 and we know torque is rate of change of angular momentum about the angular momentum about the center, we can say LC is constant. The angular momentum of the system is constant. What is the angular momentum? The angular momentum is nothing but RA cross M1 VA plus RB cross M2 VB. That is a constant. The angular momentum. This is the angular momentum of the first particle and this is the angular momentum of the second particle. So for central forces, we can conserve angular momentum about the center and the linear momentum about the center with respect to the frame attached to the center is always 0. Thank you.